Welcome back to Unit 4. In this lesson, we'll talk about Jefferson's method of apportionment. After Congress passed the Act of Apportionment in 1792, which was sponsored by Hamilton, Hamilton's arch enemy and Secretary of State Thomas Jefferson encouraged President George Washington to veto the bill, and he did. And here's how Jefferson convinced Washington to do that. It just so happens that both Jefferson and Washington were from Virginia. Under Jefferson's method, Virginia would get an extra seat. To avoid more conflict, Congress went ahead and passed this bill instead, and the first House of Representatives was established with 105 seats. Jefferson's method ended up being used until 1832. Jefferson's method relies on something called a modified divisor, and we'll use that in place of the standard divisor. The idea is that we use a different divisor in place of the standard divisor so that the lower quotas work and add up to the number of seats. The new quota that each state gets by this modified divisor is called that state's modified quota. We will use the letter D for modified divisor. We've already seen that if we add up every state's lower quota, there's a potential for the total seats to be too low. In order to bring this up, we want to divide by a smaller divisor. That means that for this method to work, our modified divisor will need to be less than or equal to the standard divisor. It is possible that the standard divisor does work with lower quotas, and in that case, we could use it. But if our totals are too small, we bring the divisor down to bring the totals up. Each state's modified quota, then, is its state population divided by this modified divisor. Let's take a look at our class example to see how this works. We'll start with each state's population and their standard quota. The standard quotas should always add up perfectly to the number of seats, in this case, 250. Rounding everyone down to the lower quota, we only add up to 246. This is too small, and so to bring it up, we will choose a modified divisor that is smaller than the standard divisor. In this case, with a population of 12.5 million and 250 seats in Congress, we have a standard divisor of 50,000. So let's try a modified divisor D that's smaller than 50,000. Maybe we should try 49,000. Written in millions, this is 0.049 million. Now we'll calculate each state's modified quota. We'll take the population for each state and divide it by our new modified quota, 0.049, or 49,000. For state A, this will be 1.646 million divided by 0.049 million. Putting this into our calculators gives us a modified quota for state A of 33.59. For state B, we calculate the modified quota by finding 6.936 million divided by 0.049 million. This gives state B a modified quota of 141.55. Continuing in this way, we can find the modified quota for each state. Now that we have the modified quotas, using our modified divisor of 49,000, we can round all of these values down and see if it adds up to the right number of seats. Unfortunately, this adds up to 252, so we shot up too high. We started out too low at 246, and we came up too much to 252. That means we dropped down with our modified divisor a little too low. Now we have to go back and try a different modified divisor. This time, let's try the modified divisor of 49,500. 50,000 is too high, 49,000 is too low. So we'll try 49,500. We will again take each state's population and divide it by our modified divisor. Written in millions, we can express this modified divisor as 0.0495. For state A, we now have 1.646 million divided by 0.0495 million. This gives us a modified quota of 33.25. For state B, we have 6.936 divided by our modified divisor, 0.0495. This gives us a modified quota of 140.12. And continuing this way, we can find the modified quota for each state. Now let's round each of them down and see if it adds up to 250 this time. Adding these new values up, we do get exactly 250. So we have now apportioned the 250 seats of Congress to these 6 states. So here's the basics of Jefferson's method. He wants to be able to use the lower quotas. That is, he wants to be able to round everyone's quota down. But if the standard divisor does not work and the lower quotas don't work, we need to use a modified divisor that will create modified quotas that will work when we round down. There are some obvious drawbacks to this method. One is that it's difficult to implement. As we saw here, the first modified divisor that we tried didn't work. And it may be necessary to try multiple values for D before one finally works. Another red flag with Jefferson's method occurred in 1832. New York had a standard quota of 38.59, and New York received 40 seats. With a standard quota of 38.59, New York's lower quota would have been 38. New York's upper quota would have been 39. But New York managed to get a whole nother seat above that with 40 seats. According to the quota rule, every state should be apportioned either its lower quota or upper quota. Anything lower than the lower quota is called a lower quota violation, and anything higher than the upper quota is called an upper quota violation. So in 1832 with New York, this is an example of an upper quota violation, which unfortunately can occur with Jefferson's method. And those are the basics of Jefferson's method of apportionment.